How do modulation techniques recover original signals? Imagine trying to listen to a song on a radio station. The station sends out a signal that's been changed to travel better through the air. When your radio receives it, it needs to turn that signal back into the original music. That's what modulation techniques do in signal processing. They change the original signal to make it easier to send, and then they help recover it at the receiver end. The process of getting the original signal back is called demodulation. It's like unwrapping a gift to see what's inside. Different types of modulation need different methods to do this. Let's look at how this works for some common techniques. In amplitude modulation, the amplitude or height of the carrier wave is varied according to the original signal. To recover the original, the receiver uses an envelope detector. This device tracks the shape of the wave's envelope, which contains the original information. It rectifies and filters the signal to extract the base signal. Since amplitude modulation creates sidebands with the same info, the demodulator can pick up the message from either sideband. For frequency modulation and phase modulation, the process is a bit different. These techniques change the frequency or phase of the carrier wave. To recover the original signal, the receiver uses a frequency discriminator or a phase-locked loop. These devices detect changes in frequency or phase and convert them back into the original amplitude variations. This way, the message signal is retrieved from the angle changes of the carrier wave. Digital modulation techniques like amplitude shift keying, frequency shift keying, and phase shift keying encode data into discrete changes of the carrier. To recover the data, the receiver first reconstructs a reference carrier that matches the transmitted one. Then it mixes the received signal with this reference to produce baseband signals called in-phase and quadrature components. These are then sampled and mapped back into digital bits using decision algorithms. For example, in binary phase shift keying, the phase of the carrier shifts by 180 degrees to representing binary 0 or 1. The receiver compares the incoming phase with a local reference to decide what bit was sent. Quadrature amplitude modulation combines amplitude and phase changes, so the receiver separates these components using coherent detection. It then processes them to reconstruct the original digital data stream. Throughout all these methods, filtering helps remove noise, synchronization aligns the receiver with the transmitter, and decoding turns the processed signals back into the original message. These techniques are used everywhere, from radio broadcasting to satellite communications, ensuring the signals you receive are accurate and clear. In essence, modulation techniques recover original signals by using specialized demodulators designed for each type of modulation. These demodulators reverse the changes made during transmission, often by matching the carrier's phase or frequency, filtering out unwanted signals, and decoding the data. This process makes sure the message you get is just like what was sent, keeping communication clear and reliable.